Hello, Dr. K here. We're going to do problem 6.8.53. I got a share application screen. And let's go to the problem. There it is. All right, so there's the problem. 6.8.53. Now the numbers are changed because it's every time you open the problem, the numbers change. So let me make this bigger. That's the first thing you always want to do, make it big. Paint supplier has two machines, produced indoor paint and outdoor paint. To meet one of its contractual obligations, the company must produce at least 45 gallons of indoor paint and 105 gallons of outdoor paint. So machine one must make 3 gallons, 45. Okay, so machine one is X. It does indoor paint, 3 of them. Machine 2 does 6, so 3X plus 6Y has to be greater than or equal to 45. So that's F, that's correct. And then machine 1 makes 14 gallons of outdoor paint, so that's 14Y. And machine 2 makes 7, so that's 7X plus 14, 14X plus 7Y equals, or is greater than or equal to 105. Boom. Make sure, yeah. Machine 1's X, so 14X. Machine 2 is Y, so 7Y. So that's the minimums for the two machines. And then obviously they both have to be greater than or equal to 0, which doesn't really matter, but we'll include them because it is true. And then that's it. The other ones are distractors. So check answer. Okay, good work. Now we want to draw those. First, the objective function. So the objective function is the last sentence. Machine 1, it costs $31, so that's 31X. Machine 2 costs $35, so that's plus 35Y. So that's going to be the function that we either minimize or maximize, depending on what they're looking for. So check answer. Okay. Now, we want to draw the constraints. So the first two are easy. That's going to be, if I hit this, there you go, there's my, they're all solid lines. So like it's the x-axis and the y-axis. So there's the y-axis. And there's the x-axis. Now, we'll just start on the upper left. 14x plus 7y is greater than or equal to 105. So if I do an xy, if x is 0, y is 15, because 7 times 15 is 105. And then notice that if y is 5, then x is also 5. That's 21 x's and y's. If they're both 5, that's 21 times 5 is 105. So that point is, what did I say, 5, 5. So we'll draw that one. So for that line, it's 0, 15. Oop, wrong one. 0, oop. Okay, I got to clear that. I got to start over, unfortunately. I made a mistake. I hit 16 instead of 15. So here's my y-axis. Here's my x-axis. And then we said 0, 15, and 5, 5. So there's 5, 5. Okay, so the second inequality, the line is 3x plus 6y equals 45. Now, for that one, when y is 0, x is 15, and 5, 5 works again because there's 9 x's and y, so 9 times 5. If they're both 5, you get 45. So for this one, it's 15. Let me draw the line. 15, 0, and 5, 5. So we know where they cross at 5, 5. Now, the constraints are for both of them that it's greater than. So the arrows point up and away. This is the big region up here, so it's an unbounded region. So this is going to be my region, feasible region. And so let's check, and that's correct. Now, I only have 3 corner points, three feasible vertices. I like to call them corner points, but they can call them vertices. It doesn't much matter. So if I plug in the values, let's see. Well, first I want to determine the vertices. Okay, so let's do that first. I was already getting ready for the values. So if we start at the top, that's 15 or 0, 15, excuse me, 0, 15. Second one is 5, 5, and the third one is 15, 0. So those are my 3 vertices. Okay, we're good to go. Now they want to know how many hours should each machine be operated to fill a maximum. So now I just figure out which one's a maximum. So if I use the point 15, if I start on the upper on 15, 0, that's y is 15. So that'll be 35 times 15. I can open the calculator. We can do it with a calculator. Oop. For some reason, it doesn't want to open. So I got to do it by hand. So if I do 15 times 35, I get 525. You can't see this, but I'm working with pen and pencil, and they're all going dry on me. Must be old. Okay, and then if I do 5, 5, that's 5 times 31, and 5 times 35. So if I just add them together, I get 66 times 5. It's easier to do it that way. So that's 330. And finally, if I do x equals 15 and y equals 0, that's 15 times 31. So that'll be 465. So the maximum is 525. And that means that it should be 0 hours for machine 1 and 15 hours for machine number 2. That would maximize the process. Oop. Okay, I did something in error. Oh, it's a minimum. See, I didn't read the question. I thought it would be a maximum. For a minimum cost, that'll be 5, 5. So 5 hours for each would be a minimum cost. Ooh, those of us that don't read the directions. There you go. Okay, so it's a minimum. And the minimum cost was $330. Answer. Okay. So for this one, just remember that it's unbounded region. You have to make sure when you test the inequalities that you get the arrows in the right direction, and they're all pointed up away from the origin, including x greater than or equal to 0 and y greater than or equal to 0. If we didn't have those, then we wouldn't have the corner points. That's why we need those 2 vertical and horizontal lines. Okay, so that's it for problem 6853. This is Dr. K, and I'm going to sign off. Boy, I hope this